Okay, so I ask you to start by pausing this video and reading this problem and then unpausing it and we'll talk about it. Okay, so let's start filling in things that we know. So they say that the standard deviation is 0.75. And this engineer wants to know if the recalibration resulted in more consistent. So more consistent means that the standard deviation was smaller. So standard deviation was less than 0.75 is what we're testing. So let's start by n. N is the number of the sample size, which is 3, 6, 9, 11. So the degrees of freedom is 10. S squared is our sample standard deviation squared, or our sample variance. Now, I don't know that, so I'm going to need to go to my calculator and edit, and if you don't already have this data in your list, you'll need to add it. But I'm going to go to Stat, Calculate, One Variable Stats, and I'm going to choose L1 and calculate. And so if you look, it does tell me that the S is 0.64. Let's just use 0.64. So S is 0.64. So S squared is 0.64 squared, which is 0.4096. So obviously I rounded pretty quickly, which means it might be off a little bit, but ultimately we should be okay in terms of rejecting or not. And then sample or sigma null squared, I guess is how I would say that. So the sigma from the null hypothesis, which is 0.75 squared. So 0.75, my computer's dying. Hopefully it doesn't die on us while I'm talking here. So 0.56, what was it? 25. Okay, so calculate the test statistic. Is this, what's it called? An equation all the way up here. So in order to find the test statistic, I'm going to take n minus 1 times s squared divided by the null standard deviation squared. So n minus 1 is 10 times s squared is 0.4096 divided by 0.5625. And so the reason why I find all those things separate is because then that formula is a little less daunting. So 10 times 0.4096 divided by 0.5625. So I get a test statistic of 7.28. So because of the inequality symbol in H1, this is a left-tailed test. And so when I think about the picture and the critical, so I need to find the critical value because I need to know whether this 7 is in the shaded region or not. So compare the test statistic to the critical value. So the critical value is the degrees of freedom, which in this case is 10. And then they say alpha is 0.05. And so keep in mind that this chart, which right here, this chart is area to the right. So if for a left-tailed test, alpha is 0.05, I'm actually going to be looking at 0.95. So I'm looking at 10 and 0.95, which is 3.940. So when I think about the critical value is 3.940. What that means is that the cutoff point is 3.940. So 7.28 would be over here somewhere. So since it's not in the rejection zone, we will not reject. It's not in the shaded. It's not in the rejection zone. We will not reject the null hypothesis. And not rejecting the null hypothesis means that there is not enough evidence to conclude that the alternative hypothesis is true. So interpreting it would be to say there is not enough, there is not sufficient evidence to conclude that the new calibration results in more consistent weights.